Okay, in this video we will cover rationalizing numerators or denominators. Okay, so what is that? The process of writing a radical expression as an equivalent expression, but without the radical in either the numerator or denominator is called rationalizing the numerator or the denominator. Okay, so basically the process of getting rid of the radical either in the numerator or in the denominator. Okay, it's called rationalizing either the numerator or the denominator. So let's start with a very simple example. Rationalize the numerator. That means that I want to write an equivalent expression of this one right here, square root of 3 over square root of 2, such that I will, this radical, this square root of 3 will not show up right here. Okay, so what do we know? We know that square root of 3 squared is equal to just 3, right? So that means that if I multiply the numerator by square root of 3, on the next line I will have square root of 3 squared, and this will just result in the number 3, exactly what we want. As we can see, from square root of 3 in the numerator, I ended up with the 3. But of course, what is the trick here? I cannot just multiply the numerator by any number that I want. I have to multiply the whole expression by 1. When I say by 1, when do we get 1? When we divide the whole number, the same number by itself. So if I want to multiply the numerator by square root of 3, I also have to multiply the denominator by square root of 3, right? In this case, square root of 3 over 2 is the same as square root of 3 over 2 times 1. This ratio here is 1, right? Okay, so square root of 3 times square root of 3 is square root of 3 squared. In the denominator, I have square root of 2 times square root of 3. And this is equal to square root of 2 times 3, which is 6. Okay? Similarly, if the question is rationalize the denominator for the whole expression, now I want to get rid of the square root in the denominator, which means I will multiply it by 2, right? If I multiply the denominator by 2, in order this expression to be equivalent, I need to multiply the numerator also by 2. And in the numerator, have square root of 3 times 2. In the denominator, have square root of 2 squared. And that's equal to square root of 6 over square root of 2 squared is just 2. Okay, now especially for the very first few weeks of Cal 1, when we were going to do limits, this process of rationalization is very important. Of course, for slightly more difficult cases where we are rationalizing sum or difference, okay, involving square roots. And in that particular case, I just want to remind you of difference of square formula, which is a minus b times a plus b. A slightly more complicated case, difference of cubes, which is a minus b times a squared plus ab plus b squared, and a cubed plus b cubed, which is equal to a plus b times a squared minus ab plus b squared. And we'll see how we're going to use each one of them. Okay, so if I want to rationalize an expression, let's say the example is if the example says rationalize the denominator in the following problem, x over square root of 3 plus square root of x, okay? I want to get a number here, an expression here that will get rid of both of these roots, right? So basically I want something like square root of 3 squared, and here square root of x squared. Now how to arrive at this point here? With what do I need to multiply this expression in order to get from here to here? First of all, notice that it says rationalize the denominator, so I'm just concentrating on the denominator, okay? Whatever I multiply the denominator by, I have to multiply the numerator by the same expression. Now again, the most common mistake is to think that a plus b squared is equal to a squared plus b squared. Okay, never ever make this mistake. Okay, just don't do that. So basically I cannot simply multiply this by square root of 3 plus square root of x, because that will not lead me any, I mean I can, but in that case I will not get rid of the square root. In order to get to square root of 3 squared minus square root of x squared, I look at difference of squares formula, and I multiply the denominator by its conjugate. I'm pretty sure you have heard this expression up until now. So the conjugate is when you change only one sign in the expression, right? So you have square root of 3 plus square root of x, and I multiply by square root of 3 minus square root of x. So if this is your a plus b and this is your a minus b, by the difference of squares formula you get a squared minus b squared. Okay, so that means in the numerator I have to copy the same expression, and you have x, don't forget the parentheses, square root of 3 minus square root of x, which gives you x times square root of 3 minus square root of x over, and now square root of 3 squared is 3 minus square root of x squared is simply x. Okay, that's how we have rationalized the denominator. As you can see, there are no square roots in the denominator. Be careful, x and x here cannot be cancelled. Okay, don't get trapped into that mistake. Okay, let's do another example. Rationalize the numerator. Okay, and here we have a square root of x plus h, and I'm pretty sure you will see this expression when you're going to do limits, or when we will define what the derivative is divided by h. Okay, I want to rationalize the numerator, okay, which means that I have to multiply it by its conjugate. Again, it's difference of two terms, right? Difference of a minus b, right? I have to multiply by its conjugate, which is just going to be square root of x plus h plus square root of x, and I have to divide it by the same thing, square root of x plus h plus square root of x. Okay, by the difference of squares formula I have a minus b times a plus b, that results in a squared minus b squared, by this formula right here. Okay, divided by, if I rationalize the numerator, then I just simply copy the denominator and vice versa. So my concentration is in the numerator, but of course I have to follow through what happens in the denominator also. Okay, so square root of x plus h squared is just x plus h, and here square root of x squared is just x, the sign stays here, divided by h square root of x plus h plus square root of x. It's always helpful to simplify this expression. What can we simplify here? X minus x is 0, and we're left with h over h square root of x plus h plus square root of x. And then again, now I have a product of two factors in the denominator. The same factor h appears in the numerator. I cancel h and h. I've seen throughout the semesters when students do this, very few, but still there are some that think that when you cancel numerator and denominator, when you divide by the same factor, you end up with 0. H divided by h is 1, not 0, right? X minus x is 0, but h divided by h is 1, and then you have x plus h plus square root of x. Okay? Let's see if I can. Okay, so let's rationalize. The denominator. This is a very interesting problem where you will see the difference between these two formulas, which some of you might think is the same thing. Okay, so rationalize the denominator. Okay, so I concentrate on the denominator where I have a plus b. Okay, in order to get rid of the roots, I want to get a squared minus b squared. In that case, I have to multiply the denominator by a minus b, top and bottom, right? So basically I have to multiply this expression by 1. That's why I'm going to write the same expression in the numerator and the denominator. So a square root of x, here I have square root of x, minus the conjugate 2 times square root of y. And the same expression has to appear in the numerator, square root of x minus 2 times square root of y equals, okay, exactly what we needed, square root of x squared minus, be careful now, b is 2 times square root of y, so 2 times square root of y squared. But now look at the numerator. The numerator is the same expression multiplied by itself, right? So if you have a times a, that simply becomes a squared. So this is square root of x minus 2 times square root of y. Can I cancel these terms right here? No. So again, don't fall in this trap. A squared minus b squared is not equal to a minus b, the whole thing squared, right? Rather, a minus b squared is a squared minus 2ab plus b squared. Okay? So the denominator is simple. That's x minus 2 squared is 4y. And in the numerator I have square root of x squared minus 2 times square root of x times 2 square root of y plus 2 times square root of y squared. And as you can see, I cannot cancel the numerator and the denominator. This is x minus 4 times square root of xy plus 4y divided by x minus 4y. And we'll do one more example. Again, rationalize. Let's say the numerator here. But be careful, the numerator here is cubed root of x minus cubed root of 3 divided by x minus 3. So I need to multiply this by the conjugate here, right? But the problem here is that I don't have square root of x minus square root of 3, in which case I just multiplied by square root of x plus square root of 3. I have cubed root of x minus cubed root of 3. So in order to get rid of that cubed root, I need to get cubed root of x cubed minus third root of 3 cubed. So basically I need to use the formula a cubed minus b cubed, one of those three formulas that I wrote at the beginning of this video. And recall that this is equal to a minus b times a squared plus ab plus b squared. So in this case, this is our a minus b, right? A is cubed root of x, b is cubed root of 3. And in order to get to a cubed minus b cubed, I need to multiply the numerator by a squared plus ab plus b squared. Of course, numerator and denominator, top and bottom, right? So if a is cubed root of x, then a squared is cubed root of x squared plus a times b cubed root of x times cubed root of 3 plus cubed root of 3 squared, the same expression in the denominator. Cubed root of x squared plus cubed root of x times cubed root of 3 plus cubed root of 3 squared. Okay. Now the numerator, following this formula, just becomes this, right? And in the denominator I have x minus 3 times cubed root of x squared is cubed root of x squared plus cubed root of 3x, right? I just, by properties of radicals, I multiply this, plus cubed root of 3 squared, which is 9, right? Cubed root of 3 squared is equal to cubed root of 3 squared, which is cubed root of 9. Okay, cubed root of x cubed is simply x minus cubed root of 3 cubed is 3 divided by x minus 3 cubed root of x squared plus cubed root of 3x plus cubed root of 9. And as you can see, here we have the same factor appearing in the numerator and the denominator. That's x minus 3. We can cancel that. And our final answer is 1 over cubed root of x squared plus cubed root of 3x plus cubed root of 9. So be careful in this case where cubic roots are involved in our radical expression.